Good morning, mathematicians. I have no idea what we're going to talk about today. As usual. Wonder if anything's going on Reddit. Infinitely scroll mathematics? This sounds dangerous. Hello, Edit Smith. This project is a fork of Wikiscroll. Doom scrolling mathematics. Oh, I see. So it's just random math pages. Interesting. Most of them are Stack Exchange, though, or Overflow. Looks like so far, which, like, fine. Hello, Dason. Hello. Yeah, I'm in an Epsilon neighborhood, within an Epsilon neighborhood. I think. Who knows? I'm stuck on something tricky. Wow, this is kind of interesting. Oh, I didn't mean to click on that one, but as if I needed another way to doom scroll. Okay, so here's the thing. There is this I'm trying to do a lot of stuff, but there's this result of Chris and Ginsburg where let me just write it out, and then actually, in order to get the symbols right, it's like psi phi equal to sum of the dimensions of what is it? You wonder how many people came out of conversation. How many papers came out of conversation and comments of Stack Exchange? Well, probably a few. Definitely. I know I've definitely seen some papers that have said as much in their introduction. They're like, "Oh yeah, this grew out of a conversation," and then they posted a link to the discussion. So, yeah. Definitely a non-zero number. Probably a few. Where is it? Yeah, I guess I don't need to write out the whole thing. I can just show it to you in this book. Yeah, so the result is where'd it go? Am I blind? Yes. There we go. This is the result. It's this one right here. So, right. Your eyes are here, but your brain may not be. Yeah, well, same. Until my coffee hits, anyways. So, wait, what am I going to... I wrote something weird. Phi. Yeah, sub psi. Yeah. So, we have these two multiplicity things. So, what are these statements? Sorry, what did I do? This should be phi. Should be phi. This should be psi. Okay. Random question, but what's the process of uploading an archive? Like, if you read a paper, can you just upload it? Or does it have to get reviewed or something before? I'm a little confused by that, because when I uploaded a paper, my preprint, like a month or two ago, I was just able to upload it. But that's maybe because, like, I have an institutional address, and maybe, like, my name was on file already from my undergrad thing. I don't know. Because there was someone posting on Reddit, actually, the other day, who was asking for someone to look at their thing and ask if they could, like, be a reference or something, or like you need someone to, like, vouch for you. So I'm guessing that if you're, like, not tied to an institution, yeah, if you're not tied to an institution, maybe you need someone to vouch for you. I think it was reddit.com/r/mathematics, which is different than R math. Did I hear about the IMO thing? Yes, the AI IMO. You're just starting grad school next month, feeling a bit tense. Yeah. I mean, yeah. Well, it depends what you're starting grad school. I don't know. I think it's just going to be a tool that will make doing mathematics easier, and will do things so much faster and crazier. You know, like day one of undergrad will be infinity topoi, and you'll just use AI to help you. Yeah, did this guy's post disappear? Maybe it did. I didn't comment on this guy's post, but I almost did, because it was very, very elementary. It was just about finding, like, cube roots of numbers. And I almost thought about commenting on their post and just being like, hey, it's cool that you're interested, but, like, maybe that's better for a blog post. Because, yeah, it's just too elementary of a thing to be an archive. Even though, like, yes, sometimes there's like expository papers and whatever. Yeah, but maybe their post is gone. Get ready to learn as much as you did in the past 10 years, but in one semester. Yeah. I mean, yeah. Hello, duck with a monocle. Yeah, I don't know. I mean, computers have been better at us at chess for a long time, but we still play chess with each other. So I think we'll still do math with each other, even once computers can, like, you know, Also, I think it'll still be a while before they're like, well, I don't know. I guess they could invent theories, right? Because like you could just feed in enough explanation of how some person invented some approach to solving some problem, and then maybe it, just happens to barf out a useful combination of words after. Yeah, I don't know. But in my other point, where people will still be doing math, I mean, there's maybe a more realistic thing where we can't justify the existence of our jobs as easily as pure mathematicians. Applied mathematicians will still have jobs, but they'll basically be using yeah. I should be using an ad blocker. Unblock origin is open source. Oh, why does it blocks ads on Reddit? Like this ad? I guess I'll take a look at that. I guess seeing the occasional thing like this has never really bothered me all that much, and I use the Brave browser when I'm watching YouTube, because it just blocks all ads. So life's been fine, but maybe I'll look into that to block other annoying ads. But I kind of like when a website sucks me into buying a new Springer text. I've not done the final presentation for my dissertation. I haven't even submitted my thesis. I'm not that close yet. I definitely don't think I can stream it. But actually, I forgot. I have a recording of a talk I gave recently that I will upload. And I have some other things to upload as well. Just re-edits of older interviews with somewhat improved sound quality. K-theory is applied homotopy theory. Yeah, I guess you could. So you're safe. Exactly. Yeah, that's how we're going to survive. Shifting goalposts. So, okay, what the hell is going on here? Well, this is the cohomology of some geometric thing. This is the Borel-Moore homology of some geometric thing. But they're given the structure of modules over some algebra, which is isomorphic to an affine Hecke algebra. But there's things to consider. And then the thing on the right is a simple module. And this number here refers to the multiplicity, how many times this simple module shows up in this module. And there's two formulas given by Chris and Ginsberg. One of them is about the restriction of a perverse sheaf to an orbit and summing over its cohomologies. So recently I talked about an example there where that's actually what it means to understand a perverse sheaf. But then the other one is this more complicated kind of restriction, so if we have some maps, we have a map between categories, we can push forward our sheaves and we can pull back our sheaves, and we get adjunctions here. And in fact, in general, there's also an exceptional push forward. It's like a push forward with compact supports. So we get this triple adjunction. By the way, this is more or less, well, it's neither a special case nor is it a generalization necessarily. So Descent, you said sounds like ring theory, but with fancy words. Well, actually, here's a corresponding story. If you have a homomorphism of rings, right? So in the case when R and S are commutative, this is a special case. Well, actually, okay, I need to be careful because we're actually dealing with OX modules, and that the quasi-coherent OX modules, and that's what corresponds to modules. But okay, there's other things going on. So, but these are kind of the same sort of idea. And again, yes, we get between our module categories, there's extension of scalars and restriction of scalars. And I might have put the adjunctions on the wrong or whatever. I always forget. And an exceptional push forward or co-extension of scalars, we might say. But then you might ask a very naive question. Well, I could write a lower star and an upper star, and I can write a lower shriek. Is there some sort of upper shriek functor that exists? And it turns out no, not on the level of the sheaves or the modules, but yes, if you're willing to go up to the derived category. So, well, let me put a D here and a D here, and if now these all mean the derived versions of these functors, then we also get an upper shriek to complete our little adjunction family. So that's nice. And that is exactly what the upper shriek is. But so it's kind of mysterious. And the thing is, I would like to understand what these things are specifically. So they're labeled these phi and psi. We've seen them before. These are basically just pairs where you have an orbit and a local system on that orbit. So that's what these symbols refer to. They're these pairs. The amount of DLCs in math is crazy. Yeah. Yeah, you pay for your $60 base sheaf game, but then, life gets really fun when you unlock the exceptional pullback DLC. And so one of the things I'm stuck on is understanding this. Well, the problem is there's some work that connects the affine Hecke modules, shall we call them, in the sense that I understand them, to this quantity here. But what I'm really interested in is this multiplicity formula here. So somehow I need to find the relation between these two formulas. And, well, Chris and Ginsburg do go on to say, I'm not sure I would call it quite proof, but at this point I'm willing to just believe it so I can finish my thesis, that they define some sort of like contragradient type operation on these modules, and they say that this module, it's dual to this module. So those are the two modules appearing in the multiplicity formula. Nice, awesome, cool. Okay. And it turns out, if you have the for what am I trying to say here? Actually, yeah, usually if you pull back to a point, wait a second. Now I need to see something. Now I need to see something. My guess, I've gotten myself turned around about a statement, but my guess is that the fix has to do with constructability. Because I thought they were going to say, there's a statement in here about the exceptional pullback to a point agreeing with yeah, I mean, there's this. Yeah, no, this is 20th century math. This is old stuff. This is, I mean, yeah. Oh, okay, interesting. Yeah, so this is representation theory and complex geometry by Kristen Ginsburg. It's like the Bible to my, one of several Bibles for my thesis. So what was I going to say? Yeah, I think I've mentioned on the channel before when I was at a conference in Maryland, David Vogan, who put forward a bunch of the ideas I'm working on. Yeah, he made some comment about how everyone there is in the 21st century and he's in the 20th century still. Because, of course, like, half the people there were all talking about, like, the derived infinity category of quasi-coherent sheaves, on a stack and blah, 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 all this stuff. And it also made me feel like, wow, I'm getting left behind in the dust here. I need to learn this crazy infinity category perspective that everyone else seems to be working on. But whatever, here we are. Okay. So now I'm confused. Yes, right. So, right. So if it's the IC attached to an orbit, which is a point, and then you pull back to that point, then you get the quasi-isomorphism. Okay. Right. So that, right. So that all still checks out. So then, if we used this formula, so it turns out, gosh, how do I explain this simply? Well, I guess I don't have to tell you all the, you feel like a crank when you use big words like that. Yeah. Like infinity category. There's a whole new, there's a crank that made his own subreddit for 0.9 repeating equals 1. Sometimes you feel like the ultra finitist had it right all along. Me too, Boris. Me too. Yeah. To be honest, I legitimately have a soft spot in my heart for ultra finitism. I think it's a perfectly defensible position. I just happen to not be one in practice, but yeah. But I don't know. I don't know. I go back and forth on the issue. I kind of think you're right. Especially since we can ever just R infinite nines. Yeah, that's the one. That's the one. Yeah. But I don't know. Maybe OP is a performance artist. I wonder this too sometimes when there's I mean, I don't know. It's also very believable. There's some people that are just like, they are just total cranks deep down, in the truest, purest way. But sometimes, when there's long-standing cranks like this, I almost wonder, I'm like, well, is it some sort of like, yeah, maybe some performance art piece of sorts? I don't know. Could I pull it off? Maybe I should have an alias that's a total crank. I don't know. But it turns out in this scenario, Wittgenstein convinced you to study math. Because everything's a word game anyways, so why not why not just play the most rigorous word game that we have? But unfortunately, we all have to do infinity category mumbo jumbo. Yeah. Is it unfortunate? I don't know. I feel like, I mean, there seems to be this looming promise that if I understand infinity categories, then everything becomes easier. Like I can take limits of derived categories and so on, etc. Yeah. Yeah. But then again, I don't know. Like maybe the way to do it is, just squint my eyes, pretend these stacks are really varieties, pretend the, objects of QCO, the infinity category QCO on that stack are just honest to God sheaves. And I think a lot of things just formally work out the same, right? You just have the same adjunction theorems and whatnot. So I don't know if I just more brazenly accepted these things and pushed forward. I feel like maybe I would make some progress or something. I don't know. I don't think this will be applied ever. Not even the year 3K. Yeah. Yeah. Anywho, will we ever get an OSU stream? What is that? What is an OSU stream? So if I let P naught be the perverse sheaf associated to the constant sheaf on the closed orbit, which in this story we have a unique closed orbit, this will ends up just being like a shifted. I mean, it's just the constant sheaf in degree 0 on the point. And so if we use this multiplicity formula, we find that this thing as a module is isomorphic to the irreducible module attached to the trivial sheaf by whatever mysterious procedure I haven't explained. But then also we know that this is, in this special case, this is the exceptional pullback of this thing. And so using the second formula, we know that this is the Borel-Moore thing. Great. And so by this duality statement, where did I put it? Down here somewhere. By this duality statement, we know that in the particular case for the closed point, this module and also hence the irreducible is self-dual. Okay, nice. blew your mind the first time you read it because it was what you always felt was true intuitively, and he explained the Schiefer stroke somewhere. I don't know what that is. Maybe I need to go read more Wittgenstein. Maybe I do. At least from the summaries of Wittgenstein's ideas that I've heard, I like what I've heard. So now here's what I think is true. And it's what I hope is true, or I think that it follows. I hope that it follows that I could prove that for all of these simples, they're fixed by this duality operation, which you might think makes it trivial, but not necessarily, because that doesn't mean that these are fixed, because even though all the simples are fixed up to isomorphism, it could do interesting things on the extensions of the objects. But what I do hope, I hope the second thing that what would be a consequence of this is not that the objects, these other objects, are fixed, but rather that they're fixed in the Grothendieck group, which is to say, this object and its dual have the same composition factors. So not isomorphic as modules, but have the same composition factors. If that were the case, I would be very happy and I could go about my life. And I mean, the other way to phrase this that would make my life easy if it turned out that these two numbers were equal. So definitely, like, it won't be true in general that these different pullbacks will be isomorphic. Absolutely not. But it is still conceivable to me that in the situation I'm in, if you happen to take these two different pullbacks, and you take all the cohomologies, and you sum up the dimensions, and you ask about the number of times some specific local system shows up in there, then maybe those numbers end up being equal. It could also have something to do with the fact... No, I don't know. Also, for the case I'm interested in, I just want to know how many times the constant sheaf specifically shows up in these. So maybe that makes life easier. I don't know. The other thing is there's this thing called Verger duality, which allows you to generalize Poincaré duality to weirder spaces. And so the Verger duality, if you apply it twice, you get the identity. So then my hope for computing these things, is that so plug in the Verger dual. Well, I hope I can do something with this. So plug in the Verger dual twice. Then it turns out if you try to pull one of the D's through, it changes this exceptional pullback to just an ordinary pullback. Nice. And then secondly, in this case, so this is, the intersection cohomology attached to some orbit. And, in this particular case, in fact, it's the intersection cohomology attached to this orbit with the trivial local system. And it turns out that if you take the Verge dual of this, it's just itself again. In this very particular case, that's not a general phenomenon. And so we just get this. And so now, I mean, this does look a lot closer. This does look a lot closer to this formula, right? But now, I don't know. I feel like there's got to be some theorem out there already that allows me to, like is the effect of this of Verge duality on the orbit just to shift this complex? I feel like that's true. I think that's maybe a theorem I could massage out of some other things, given some of the assumptions I have. And then, so it wouldn't say that it's the same as this, but it would maybe tell me that once I sum up overall K's, maybe they're equal. I don't know. What's a good example where all these equalities are satisfied? Well, Verge duals aren't idempotent. Idempotent is just like you put it to a power and you get the identity, right? Yeah. Not up to some weak equivalence. Yeah, I mean, in the up to isomorphism in the derived category. Up to isomorphism in the derived category. This is, isomorphic to the identity functor. That's why it's called the dual. Apply it twice, you get the identity back. Yeah, so an example where these equalities hold, well, I mean, there's a whole bunch of examples. When proving two numbers are equal, it seems like modern mathematicians have gotten a lot of mileage out of the pigeonhole principle. Yeah, I don't think that's going to help here. I don't think that's going to help here. So, I mean, basically any example, So the examples where this is true. So I mean the general conjecture, right? The Piatek-Castan-Lustig hypothesis basically says, well, the multiplicity of a standard representation, whatever that is, it's supposed to line up with the versions above, which I'm trying to elucidate some of the details on. This is an irreducible. This is the standard representation attached to a maybe different irreducible pi. Should work out to be this sum of, okay, this is a perverse sheaf attached to pi, and you restrict to this orbit in some geometric space attached to this irreducible representation. And so yeah, I guess, I don't know, like so there's some basic cases where I could work this out. But actually, I mean, I guess I need to even articulate what these things are in general. So I guess I do need this self-duality statement. And so what are cases where it's true? Well, I can definitely prove it's true in the case where so there's this example we've been talking about the last couple of weeks or days, whatever, where we look at this stratification. It turns out this is an example of one of the varieties I'm interested in. And in fact, life is even easier because I purposely made that example slightly more spicy by having the group acting on here to act by T acts on Z by squaring. But actually, a more basic example, which also shows up, is just T acts by multiplication. And, you know, so we worked out, in that case, we worked out the, what should I say here? Like, the, well, I guess, did we work out the perverse sheaves? We worked out the demodules in this case. And I computed one of the perverse sheaves using Riemann-Hilbert. But there's like a more combinatorial way to do things. So we have two orbits, and I'll call it C1, C0. And we'll take the perverse sheaves associated to each of these. And yeah, what's a good way to write this all out? Maybe I should do this tomorrow. I should probably go do some exercise. Get on my VO2 max training. But yeah, maybe we'll come back to this tomorrow. But we did work these out. So maybe what I'll do tomorrow is I'll go back and I'll work out what these are in this example, and then I'll tell you some of how it matches up with the representation theory. How about that? Let's do that. By the way, public service announcement. I'm very much on the VO2 max train, which is allegedly probably the strongest correlated thing for your lifespan and health span. So probably the best thing you can do for yourself in a 25-minute chunk of any week is work on your VO2 max. One 25-minute session a week, you could be stacking on a decade to your life. I don't know if that's exactly accurate, but anyways, it'll probably keep you healthy and happy for longer. So do with that information what you will. Anyways, time to go prove things. Time to go run fast. I'll see you guys.